Introduction to Aggregation in Java. Welcome everyone. Today we're going to talk about one of the fundamental concepts on object-oriented programming, which is aggregation. So object-oriented programming is built around several key principles: encapsulation, inheritance, and polymorphism. We're going to see how aggregation fits into this framework. Unlike inheritances, inheritance is a relationship. Aggregation defines has a relationship. So it's important to understand this distinction as we design and structure software. Definition of aggregation. So aggregation is a term used to describe a scenario where one object, which we call the aggregate, contains one or more objects. So they're also known as components. And this relationship is termed as has a, meaning that our aggregate object will have one or several instances of component object. For example, we know that a library contains books. So this relationship helps us manage complex relationships in software by breaking them down into simpler, manageable parts. Characteristics of aggregation. So in aggregation, the aggregate object owns the component. However, unlike composition, these component objects can outlive the aggregate object. So this relationship allows for a looser coupling, which means changes in the component class have less impact on the aggregate class, providing more flexibility in the system design. So let's look at this example. We have engine class. Engine class have start method, and we have car class, and car class will have a constructor that will assign, that will instantiate a new engine object and assign to the car's private variable engine. And then we can have a car start method in car as well. So we can see that there is this aggregation relationship, and we're delegating start to engine. Here is another example of aggregation. So we talked about library and books. So let's think about a library system where each library object can contain multiple book objects. Then the library class does not inherently create book objects, but you would rather hold references to these books. So this arrangement allows books to exist independently of the library. So this demonstrates the flexibility of aggregation. Here is a code example. Some of them are omitted, but we can see that we have a library class and a book class. and library class aggregates book objects, and we can see that book class has title, author, and it has constructor to set title and author. And when we create a new library and add, we would create a list of list that can contain books, and then whenever we call add book, we're going to add a book object to this book's private variable of the library. Comparison with composition. So while aggregation allows for components to exist independently, composition binds the components to the life cycle of the container. So a classic example of composition would be a house and its room. And we can see house class can have rooms, and whenever we call house method, it's going to add a new room, and which is new living room and new bedroom. And we can see that room class has a string name. So rooms typically do not exist separate from the house. So you can see that that key difference between aggregation and composition. When to use aggregation? So aggregation is particularly useful in scenarios where you need shared or no clear ownership, and where components need to be shared among multiple aggregates or exist independently. So choosing aggregation over composition can greatly affect the flexibility and extensibility of your program. Benefits of aggregation. So aggregation can provide several benefits. Aggregation offers greater flexibility in how objects are used. It definitely simplifies modifications and updates within the class structure and enhances the reusability and maintainability of their code. And these advantages make it a preferred choice in some of the complex software designs. Practical considerations. When you are implementing aggregation, it is important to manage null references to prevent any runtime exceptions. One common one would be null pointer exceptions. Also, choosing the appropriate collection type to manage groups of component object, like using lists or sets, play an important role in how effectively your program operates. So we can see here library, and when we're adding book, we are handling any null case to avoid a null pointer exception. And then when we're getting books, we are returning an unmodifiable list to protect the integrity of the collection. Conclusion, aggregation is a powerful concept in object-oriented programming that provides significant advantages in software design. I definitely encourage you to look into this aggregation concept further. understanding these relationships can definitely help you in becoming a more effective software developer. Thank you, everyone.